How we doing, Beast? How we doing today, my friend? I hope we're doing good, my dude. Where is everyone today? I don't even know where everyone is today. That's weird. I'm amazing good. Hey, Isabella, hello. Hello, hello, hello. How we doing today? We doing on this fine Thursday. What is going on? All right. I'll be back. You need to finish off a VOD review. Fair enough. Hey, Sneaky Weasel, how we doing? How we doing, my friend? How are we doing? I hope we're doing good. Doing pretty good? Good. I was wondering where everybody went to. I'm like, wait a second. It's almost 11 o'clock. I'm like, I don't see anybody online. Thinking, what's going on? I should switch to my other face cam, though. That'd be pretty okay. There we go. There we go. Probably be doing that. Probably question mark. Yeah, I know some school, but I'm getting stuff I'm behind on this weekend. Alright, that's good. As long as you get it done, then that's all that matters. Just get it done, though. Yeah. Get it done, my friend. Any plans for the weekend there? It's speech? Oh, okay. Oh, no big deal. Public speaking? I don't do any of that. Public speaking's overrated, my dude. Shh, public speaking. Volleyball tournament. Volleyball overrated. You don't need exercise. Psh, you don't need fun. You don't need none of that stuff. Okay, maybe you kind of do, actually. Maybe you kind of do. I hope you do really well, Isabella, at the volleyball tournament. Hopefully you guys can place really well. Hopefully you can win the whole thing. Volleyball tournaments, man. Sports tournaments can be certainly a little tough, but they're definitely enjoyable. What am I supposed to do? Oh, yeah. Hey, Beast is back. Hello. Welcome back. That was pretty quick. I missed you, Uncle. I've been doing good, my friend. I've been doing good. How are you? How's you? How is your girlfriend? How are they doing? How is she doing? Hopefully you and her are both doing absolutely fantastic. I do high school volleyball because I'm still in high school. Fair. Dual credit. Got a date later tonight? Wonderful. Absolutely. Nice. Dual credit too. Very good. Very good. Used to play for my high school as well as to sophomore year. Very good. Dundee Crown. So wait. Then I have a question. Are you guys just like watching this from like study hall or something like that? You know, like that's the question I have. If you're dual credit and you're watching it from like high school, you just go to You just go to study hall? Nah, from my bedroom. Oh, that stings. No, at home. And then you have to tell everybody at school, be like, no, I just take classes on Twitch. You'd be like, okay, man. All online, fair enough. That's fair. None of your... How did none of your friends understand that? What? Yes, Beast, I like football as well. Both types, American and football. Yes. How could none of your friends understand that you could conduct a class on Twitch? I don't understand that. It doesn't make any sense. Like, people say, well, you do it on Zoom. It's just another platform. Like, just without the face-to-face camera stuff. Am I doing something wrong here, guys? Am I the one that's wrong here? No, they don't understand that I'm in college. Oh, they don't understand that? Oh, gosh. Well, it's not the craziest thing I've heard. Not the craziest thing I've dealt with. They seem to think it is. I don't know. I think that's cool as heck. You get those college credits out of the way and you get it for free. That's what you should tell them. I'm like, look, you have to pay for classes in college that I already took in high school and I got it for free. You tell me who's winning in this contest. Not me. Not the person who will have a less of a student debt when they get out. Because we're gonna go down that road. Well, that's true. Free? Pay $1,300 per credit hour if you go to a college or university. Yeah. I was thinking that. It's always come down to pros and cons. That's the biggest pro. Alright. Well, ladies and gentlemen, we have just a little bit to do today. We're gonna do a few things here today. We ended off at halfway through, actually, a portion through a question from last time, so we're gonna pretty much start on that. Bring this up. Alright, we ready for a nice, simple class today? I hope so. I hope we're ready for nice, simple classes today. That's what I'm hoping. You guys ready? Let's do this. Let's do this, ladies and gentlemen. Let's go! Let's do some intros, let's go! Alright. Okay, let's get started today! Welcome back. Welcome back, everybody, to Thursday. End of the week time today. So today, we are going to be continuing where we left off last time. Last time, ladies and gentlemen, we did section 6.2. We talked about the binomial distribution. Alright, so that was definitely on our radar from last time. And today we're going to be doing some more examples with the binomial distribution, as we only got through halfway through one question. So, kind of want to, you know, do more than halfway through one question, which would be kind of nice. Question mark. Alright, good stuff. So, let's go ahead and do it, and let's see what we're working with, yeah? Okay. Alright, let's take a gander at the big board. Alright. So here's the big board for today. We're going to have a couple things going on. Oh, right. I got to make this bigger because of last time. Hang on a second. I forgot about that. If I can zoom in on this, that would be... Hey. Hello? Think I could zoom in on this? That would be pretty great. Technology. Oh my gosh. What? This really. Technology loves me, man. All right. Somehow, some way, this does not want to work the way I want it to. You gonna get the e-text again? That's okay, Robbie. What is this? Not this again. Alright, hang on a sec. I don't want it. Give me a second. The book wanted to crap out on me again, so I have everything set up and ready to go, and then the book's like, nah, I don't want to do it. Okay, bro. Why does technology hate me so much? Alright, here we go. Let's try this again. Alright, here we go. Okay. Sorry for the delay, everybody. The book was not wanting to be cooperative, but now it's cooperative. Alright. Okay, so let's take a good look here. We left off here at number 35 here last time, talking about on-time flights. And so let's give ourselves a reminder about what we talked about a couple of days ago. Now, a couple of days ago, when we first talked about the binomial distribution, we did talk about the idea that everything had to be either kind of either a success or a failure. So when we talked about this example here in 35, either the flight is on time or the flight is not on time. Now we had a formula that went with it from last time. So here's our formula right here. What's the formula for the binomial distribution? And so here it is. Again, you have the number of trials, number of successes, and whatnot. Now, the most important part that we talked about, though, was the bottom part here, which reflects, again, how we would enter this into the calculator. Because one of the things that we talked about here specifically was that the calculator was going to be, again, the calculator is going to be your best friend, but is very limited in capacity in what it can do in terms of solving for those binomial distribution type of problems. So as you can see here, we had binomial PDF, which represented exactly the number of successes, and binomial CDF, which reflects less than or equal to that number of successes. Again, if you have the new school calculator, that'll be the number, or old school calculator, either way, it'll always be reflected the same way. The number of trials, the probability of success, and the number of successes. Okay, so that is again binomial PDF and CDF. And we did the first couple parts here of number 35 from last time. But I want to go ahead and do the last two parts here from number 35 and look at some more examples here about how to work with binomial PDF and CDF. And of course, we'll go through the calculator button presses once again in order to solve for these and see what we get for our final result. All right. Let's go ahead and do that right now. Now, last time we went ahead and did parts A, part B, and C. So we're going to start with part D here. So we did the probability of exactly 10 flights. We did the probability of fewer than 10 flights. Now let's go ahead and do the probability of at least 10 flights are on time. All right. Now, again, just to let you know here, the number of flights that we tested over was going to be 15. So we selected 15 flights according to this. But we have to find and interpret the probability that at least 10 flights are on time. So at least 10 flights are on time. Now, let's go back to our handout here for just a moment. Oops. handout, please. There you go. Let's go back to our handout for just a moment here. First and foremost here, which function on the calculator are we going to use? Are we going to use binomial PDF or binomial CDF? Okay, good. So far so good. I agree with all of you. We're going to go ahead and use binomial CDF here for this problem. All right. Now the question is, we're going to be using binomial CDF in some capacity. Well, how are we going to do that? How do we figure out at least 10 here? If we use binomial CDF, which I agree with everybody, that's what we'll use, how exactly do I figure out the probability that at least 10 flights are on time, remembering that there's the limitation that binomial CDF means that it's less than or equal to? Anybody tell me here how we can basically maneuver around that limitation? What do you guys think? How can I use binomial CDF to my advantage here? How do I get at least 10? And when we did stuff in chapter 5, by the way, we did use something here. Well, 15.8 and 11. Well, in that case, Alyssa, if I did that, then that would be less than or equal to 11. But less than or equal to 11 doesn't reflect at least 10. Remember, there is a distinct difference between those two statements. If you say less than or equal to 11, that's 0 to 11. If I say at least 10, remember, has to reflect between 10 and 15, right? That's what at least 10 means. So this is what I want. I want all the cases between 10 and 15. All right, Jasmine, that's a pretty good guess. Again, that would be less than or equal to 10. So maybe not less than or equal to 10 here in this instance. Oh, Alex, that's pretty good. Okay, that's pretty close. Now, you kind of have two things put together here. But I'm going to take one of them, and let's think about it this way. Okay? Let's think about it this way. Let's visually represent what I have up here on screen. Okay? This is what I want. I want 10 to 15, right? That's what I want. So, what do I not want? What cases do I not? I want the case of 10 and 11 and 12 and 13 and 14 and 15. I want those cases. What cases do I not want? What cases do I not want here then? All right, so everything up to 9. That's right, Vince. That's right, less than 10. Correct. So if I have two sets of cases here, I have 0 to 9 and 10 to 15. I want to lop off everything from 0 to 9. That's correct. Both of you absolutely right. Now I'm going to use that idea Alex has put on here. Let's use the rule of complements. That's the key into doing this particular problem, is using the rule of complements. Remember, as I pointed out before, wording is going to be incredibly important. And because of this limitation, this is definitely where it's going to certainly be a thing. So, I'm going to do 1 minus, in this case here, what's the opposite of at least 10? If the opposite of at least 10 is less than 10, which is true from what Alyssa has said. Or, what's another way to say less than 10? If I were to use less than or equal to, what's another way, if I were to say less than or equal to here? less than or equal to 9. Okay, that's correct. So I'm just looking for, yeah, I'm specifically looking for that wording here, less than or equal to 9. All right, now I'm doing that here on purpose. Okay, so there is a reason why we're going ahead and doing that here. Okay. All right, so it's not because I'm not trying to. It's because we want to reflect this probability. Now we want to reflect this probability in terms of our definition of binomial CDF. So you both said, everybody said, okay, we're going to use CDF. True. I can't get at least 10 doing it directly on the calculator. So again, maneuvering around that restriction of less than or equal to, I can do 1 minus the probability of less than or equal to 9. Now, how can I put less than or equal to 9 on the calculator using binomial CDF? How can we reflect less than or equal to 9 on the calculator using binomial CDF? What number should I put in here for the binomial CDF function? And give me the 3 numbers, Vince. The 3 numbers. What 3 numbers I gotta enter in? I'm not just gonna put in the number 9. Come on, Vince. I know you know better because it's written right here. Alright, 15 for the number of trials, 0.8 for the success rate, and 9. That's correct. Good. Okay. So we're going to put this into the calculator here to figure out at least 10. Alright. Again, 1 minus binomial CDF 15, comma 0.8, comma 9. Alright, so let's get out the calculator here. I'm going to bring out my calculator here, of course. Alright, so bringing out the calculator here, let's go ahead and do this here together. So I'm going to do 1 minus, and then here, let's go ahead and remember, we'll hit the second key and hit the vars key to get to the distribution menu. So the second key and the vars key. And then we'll go to letter B, binomial CDF. Again, we're going to enter in our trials here. Our trials will be 15 for the first part. If you have the old school calculator, just copy exactly what I have on the screen here, right below here. And then 0.8 and 9 here for our x value, and then we'll paste that on. So it should look just like this, old school or new school calculator, doesn't matter. And hit enter, and we get 0.9389. That is the correct answer, very good. Okay, so far so good. Any questions so far? Yeah, so it will change your answer there, so you need to be careful about that, Jasmine, before you go ahead and enter that stuff in. So yeah, make sure you do 1 minus and then do the second in bars thing. That's why, again, just write it out first and then go ahead and enter in the calculator so you know what you should be entering in. Make it easier on you at the end of the day. Okay. Cool. Alright, let me try another one here. Alright, let's try another one. We'll try the last one here, and then we'll look at some more examples, of course. I think, of course, when we look at some different examples, some different ways, of course, you know, we gotta just see from every perspective here. So let's look at letter E, which is the last one there. Okay, so letter E says, find and interpret the probability that between 8 and 10 flights inclusive are on time. The probability of between 8 and 10. So 8 and 10 are inclusive. All right. So basically, again, the way you want to tackle this type of problem here is to go ahead and just visualize it out. Okay, once again, remember what you want at the end of the day. All right, you want the cases of 8, 9, and 10. That's what you want. You just want this. You want 8, you want 9, and you want 10. And you want to do it in a shorter fashion than adding 3 things up together. Because you can, but it'll take you a while to do. So, again, we're going to use binomial now. Again, are we going to use binomial CDF or PDF here? Should we use binomial CDF or PDF? Let's answer that question here first and foremost. Now, you could use PDF here because they are exact, but I will tell you this about PDF. It will take you longer to go ahead and find the answer here using PDF compared to CDF. So, in this case here, we are going to use binomial CDF here in this case. All right. That's what we're going to use here for this problem. All right. Okay. Now the question is, how do we use binomial CDF here? Again, if I want 8 through 10, I want cases 8, 9, and 10, then what I do want to exclude here is I want to exclude all the other cases that are in front of it. I want to exclude the first 7 cases. Okay? So the way it's going to work is I want to have all 10 cases, the first 0 through 10. So again, I'm going to use the idea of my binomial CDF being less than or equal to. I'm first going to have less than or equal to 10. I'm going to have binomial CDF. The numbers here, the first 2 numbers are always the same, so 15 and 0.8. And I'm going to have 10 here to start with. Okay? So this takes care of the cases from 0 to 10. Then, from what I can see, I want to remove the first 7 cases. So absolutely right, Vince. I want to have less than or equal to 7 here. So I'm going to subtract that. I'm going to subtract that by binomial CDF. And then 15, comma, 0.8, comma, 7. To reflect less than or equal to 7 that we want here to leave our cases of 8, 9, and 10 left over. Okay, so we take the first 10, lop off the first 7, and then we're left with 8, 9, and 10. And there you go. All right. Okay, and so let's go ahead and put this in our calculator. See what we get. So we're just going to do this twice. So hit second in bars. Let's go to down here, binomial letter B, binomial CDF. We'll go to 15, 0.8, and 10. Okay, so it'll look just like this. We'll hit subtraction. Then we just repeat the process again. Second in bars. Go to binomial CDF again. And now we want to hit 15, 0.8, and 7. All right, those are going to be our guys here. Go ahead and hit paste. And let's go ahead and see what we get here for our answer. So we get, let's see, we get 0.16. All right. And there we go. We got our final result. Okay. Any questions about that example so far? Hopefully that was pretty straightforward. At least it's intended to be. All right. Okay, let's try another example, and let's see if you guys can now put it together. Because now that we have an idea about the template for each one of these questions, now we should be able to go ahead and do some problems, again with slightly different numbers, but similar wording. Okay, let's take a gander here, though. All right, we'll get to those last couple of questions there later. All right, let's take a good look here at number 37. All right, let's look at 37. Look at 37. All right. In the Healthy Hand Washing Survey conducted by Bradley Corporation, it was found that 64% of adult Americans operate the flusher of toilets in public restrooms with their foot. Suppose that a random sample of n equals 20 adult Americans is obtained and the number of X who flush public toilets with their foot is recorded. Okay. We're going to answer a few questions from this. I don't know if you guys do the same. Do that. You do that? Okay. I mean, I actually don't. I actually don't. I actually just flush and then I wash my hands and then, you know, make sure get all the whatever. I can see why though. I know it's kind of surprising when I read this question. I'm like 64% is quite a bit. It's a lot. It's fun. It's fun to flush with your foot. Do you have to like do a little you have to do like some gymnastics in the stall, you know, just trying to get it to flush down, you know. The karate kick. That's fair. Karate kick the toilet. I'm like, alright, that's fine. Alright, let's try letter B. Alright, guys. The probability that exactly 12. Let's go with exactly 12. Okay. Less germs, more fun. More kicking of germ ass. There you go. What is the probability of exactly 12? Alright, type in the chat what we need to enter into the calculator for exactly 12 flush with their foot, or karate kick the toilet with their foot to get rid of them germs. Give me all the numbers there, Jasmine. Alright, good. Alright, PDF 20.64 and 12. Both of you are absolutely correct. Very nice. Alright. Alright, let's plug that in the calculator, guys. And you guys tell me, what do we get? We plug this in the calculator. What do we get? So again, second vars, PDF right above CDF, letter A. And then you could put 20.64 and 12. Anybody got a decimal answer for me? 0.1678, alright. Sounds good to me. All right, so far so good. All right, let me change the problem around a little bit. This time I'm going to do one that's not necessarily in the book, but going to use these same numbers here similarly. How about this? Again, I want you to get a few more different looks here at types of wording and things. So let's see if you guys can figure these out. The probability of at most 14. It's the probability of at most 14. Probability of at most 14. How would we figure that out? Anybody tell me what should we enter in the calculator here for at most 14? What does at most 14 mean? I'll give you a minute to think about it. Well, not a bad idea here, Vince. Not quite. Alex says CDF 20.64 and 14. That, Alex, is correct. At most 14 means not more than 14. That's true. That means less than or equal to 14. Right? It means you get from 0 to 14. So if you have a tough time kind of visualizing it out, just say at most 14. That means the max it can be is 14. So you want the cases from 0 to 14. That's what you want. All right, so that means 14 or less, if you want to kind of put it that way. It's another way to put it. So we're going to have binomial CDF. Here we get 20.64 and 14. All right, let's do this out. All right, so let's do this on the calculator here. So second in bars. Binomial CDF. All right, get 20. And 14. So here we should get 0.7829. All right. Okay. All right, any questions about that so far? Got a few more of which to look at, so a few more of these tricky word problems that I would like you to look at because, again, you could encounter these. Let's look at another one. It's okay. It takes a little time. Again, that's what I would like you to do, Jasmine. If it's having a tough time just kind of thinking about it, visualize it out and just kind of sound it out and then write down what those cases would be. Sometimes you just need to see it in front of you to know exactly what you're going to be doing next. Alright, here's a tough one. But, again, one that needs to be done. Probability of more than 15. Probability of more than 15. Probability of more than 15. Anybody tell me how we could go ahead and do this out? What cases do we want for more than 15? Let's answer that question here. If I see more than 15, what cases do we want? Let's just visualize it. Oh, we want... Oh, one of those is true. 15, 16, 17, 18, 19, 20? Or is it 16 to 20? One of those is true. More than 15. Is it 15 and up or 16 through 20? Remember, wording means everything here. Read very carefully. You were fine the first time, Jasmine. You're right. So these are the cases from 16 to 20. That is correct. Again, as we mentioned here, wording, gotta be really super careful, but it is correct. More than 15 does not include 15. So that's the temptation. Temptation is that we want to include 15, but that's not what it says. It says more than 15. So it's gotta be 16 to 20. Okay, so now that we want the cases of 16 to 20, that's fair. Alright? More than 15 implies not the value needs to be larger than 15. Yes, that's right. The value has to be larger than 15 if we want more than 15. Right. Okay, so how can we... So more than 15, not the value that needs to be larger than 15. So what cases do we want to eliminate? So we want cases 16 to 20, but what cases do we not want? Let's think of it that way. Alright, 1 to 15. Okay, good. Let's put 0 to 15 or 1 to 15. Doesn't matter. Whatever you guys want. I don't care. So we don't want these, right? Fine. How can I express that? How do I express more than 15? Now that you know what we need to do here, we want to keep 16 to 20, but we want to remove the first 15 cases. Fine. How do we do that? How did we do that before? Yeah, you could say that. Although, Vince, it would be easier. I don't disagree with that, but it would be easier for us to go ahead and use the rule of complements like we did before, because 20, 0.64, 20 will be 1, just straight up. Alright? No worries, Beast. Glad you're back. So you could just use 1, and you could use 1 minus, again, binomial CDF. And then we just use 20, 0.64, 15. So again, I want you to kind of visualize why we're kind of doing this. If it helps to visualize, then use that. That's why I'm offering it as a alternative. Love your class, man. It stresses me out even more about the future. Okay. I'm sorry. My bad, bro. So, the reason why we use 15 here specifically, Alyssa, is because we want to remove the first 15 cases. So if I want 16 or more, alright, for example, or more than 15, I need to get rid of 15 or less than or equal to 15. That's why we use 15 here. Remember, this is like, again, using the limitation of the binomial CDF function here that we talked about before. Remember, what does that mean? That means less than or equal to. So whatever we put in binomial CDF there, Alyssa, that's reflective of less than or equal to. I want to get rid of all the cases that are less than or equal to 15, so I can keep the cases of 16, 17, 18, 19, and 20. Okay? So that's why we put 15 there in that case. So we can get rid of 15 or below to keep everything above. Does that make sense? Okay, cool. Oh, I already put that down. What did I do? Okay, let me go ahead and put that in the calculator. That's what I meant to do. I don't know why I was rewriting it. Alright, we got 1011. Alright, let's check it out. I trust. Just have everybody see that. Alright, that's correct. The 0.1011, that's correct. Good. So far, so good. Okay. Alright, let's look at another one here. Let's look at another one. So we've looked at more than 15. We've looked at least, in at least case. We looked at most. All right. Let's look at this one here as well. I want to be sure I haven't done that one yet. I want to look at every single case here. Okay. All right. So let's go with probability of less than 12. Probability of less than 12. What do we do here in this case? Probability of less than 12. Or fewer than 12. You can also say fewer than 12. If you want to say that. This is sometimes written as fewer as well. How could I reflect that? Fewer than 12. Not quite there. Ah, yes, look at it carefully. It's always about the reading. Ah, there you go. Very nice. Alright, that is correct. Very nice, Alex and Alyssa. Good. This is why I have to say, what you see on screen may not be exactly what you need to enter into your calculator. I understand it's easy to fall underneath the trap. What you see is what you have to put down. That's not how it works. That's why wording here is what I've always stressed in this section. You gotta read it carefully, and then you gotta put it together. And sometimes it's not as simple as it looks. Like, I wish I could sit here and say we just use the numbers directly. Now, that's not true. Alright, so we do have to use 11 here because we're having fewer than 12 or less than 12. That's why it's not less than or equal to 12. It is less than 12, so we have to use 11 here in this instance. Alright, so knowing that, let's go ahead and put that on the calculator. See what we get. 0.2683. Alright. Second bars. Alright, good stuff. That's right. Nice. Alright. Any, hopefully that's not too bad. Questions about that so far? Questions. Alright, let's do one more then. And then we'll move on to the other half of that problem. Alright. The other half of the handout there, sorry. Okay. Alright, so let's do letter D. Letter D, just as a nice little review from what we just talked about earlier. Probability between 9 and 11. So probability between 9 and 11. So just like we talked about earlier here, probability between 9 and 11. And want to set that up and see what we get here for our answer. PF, so remember, Jasmine, we want the cases here, 9, 10, and 11, right? Oh, there we go. Okay, so Jasmine, remember our last example here from the previous problem. Our last example, we had 8 and 10, between 8 and 10. Remember, we had to subtract two binomial CDFs together. And Alyssa has the right of it here. That is correct. We're going to take binomial CDF. I know it's a little frustrating. But that's why we do the practice. Making sure we cover our bases, okay? No worries. Alright, so we did 20, comma 0.64, comma 11. That takes care of the first 11 cases. So again, if you're visualizing it out, once again, take care of the first 11 cases. You know, if we're going from 9, 10, 11, that's what we want. We want to go from 0 to 8 and 9 to 11. We want to remove the first 8 cases. And then minus binomial CDF. We have 20, comma 0.64, comma 8. All right. And you got there, Vince. You got 0.2436. All right. Okay. All right. I trust. All right. Very good. Okay. Any questions about that? Hey, 801 followers. Nice. Someday I'll make it to 1,000. You guys are what makes this enjoyable, as I always say. Many of these followers were former students or former hostages, whichever one you want to choose first. So 8/10 of the way there for the full 1,000. It's nice to be followed. People want to come to the stream every once in a while. It's all good. I think it's fun. All right. Next. Okay. Let's take a good look here at number 41. All right, so we're going to look at 41 here. Okay, 41 says 12 jurors are randomly selected from a population of 3 million residents. Of these 3 million residents, it is known that 45% are Hispanic. Of the 12 jurors selected, 2 are Hispanic. All right, let's look at letter B. If 12 jurors are randomly selected from a population that is 45% Hispanic, what is the probability that 2 or fewer jurors will be Hispanic? Okay, so we're going to go ahead and answer that question here first. Probably that 2 or fewer will be Hispanic. Well, the easiest way to kind of figure that out here, in this case, is that 45% of the 3 million residents will be Hispanic. So let's talk about proportion of the jury being Hispanic. So if there's like 2 people on the jury that are Hispanic, we're going to pick 2 out of 12. Now we can do this on the calculator. This would be for letter A. But 2 out of 12 here would be, let's do that on the calculator real quick. So we get 0.1667. Okay. All right, so 2 out of 12 here will be Hispanic if I were to look at just 2. Now, in this case, 12 of them are selected, and the probability for, and 45% Hispanic here. Okay. So let's take a look here at letter B. What's the probability that 2 or fewer are Hispanic? Well, in this case here, again, we would do binomial CDF. Here we would do, what do we have, 12, comma, what's our probability of success here? 0.45. And 2. Let's put that together. All right, so 0.0421, what we get here. Now, to kind of go along with this, again with our probability of success here is 0.421, 0.45, sorry. All right. Now, there's another half to this, not another half, but there's another part to this question here that I do want to do. And that is, we want to compute the mean and standard deviation here. So let's take a good look here. Now, the mean and standard deviation, even the variance here, is very, very simple. Let's take a look here. How do we find the mean, variance, standard deviation of a binomial random variable? Well, as you can see here on the screen, the mean here is n times p. The notation for the mean here is the mu of x that we've looked at before. The standard deviation is the square root of np times 1 minus p. All right? And again, the same notation as we've talked about before. And of course, the variance is just going ahead and squaring whatever we get for the standard deviation. So if I were to look at this situation here, in this problem for, like, say, number 41, what's the mean for this particular question? Now, with the mean here, we're just going to take n, which is 12, times p, the probability of success, which should be 0.45, which since 45% of the population in this particular city is Hispanic. So, if I take 12 times 0.45, what do we get here? Let's do that. Like, these calculations, surprisingly for mean and standard deviation, are very, very easy. Like, you don't even need to do that much work, in all honesty, to actually figure these out. So what's very convenient is you don't have to do any work. Right, we have to do very little work in order to get this done. So the mean here is going to be 5.4. We want to find the standard deviation. We just take the square root of np times 1 minus p, or we could just find the variance here first in actuality. Let's do that first, because technically, in this case, we could just plug and chug numbers in. If I want the variance, I do np times 1 minus p. So let's just plug in the numbers. We get 12 times 0.45 times 1 minus 0.45. Let's figure that out. All right, and so here we get 2.97. And then if we want the standard deviation, all we have to do here is take the square root of 2.97. And so let's go ahead and do that. Take the square root of this 2.97. And here we get 1.7234. Okay. All right, and that's how we can find mean and the variance and the standard deviation. It's very simple. The formula here is very straightforward. It requires very little to no effort to actually do. So as you can see here, normally we would be nervous about, say, this mean and standard deviation, but for a binomial random variable, it's actually fairly easy to do, as the formula there is actually extremely straightforward to use. Okay, any questions about that? Okay, well, let me go ahead and bring up the next handout here. All right. Oh, I think I brought the wrong one up. Sorry. Grab the other one. That was not the right one. Where did I put that one? Hang on a second. I had a different one. Here we go. That's what I wanted. All right. That's what I wanted. Okay, let's take a good look here at section. Let's go to the next chapter here. We're just going to talk about briefly section 7.1. Now, I know normally, let me go ahead and preface this off here. I know normally this is where we would take a break, but this section is super short, okay? So, believe me, I'm not trying to be like, get out of a break. I'm just be perfectly honest with you, this section is pretty short. I'm going to barrel through this, and then once we're done with the section, I'm going to let you out early today. All right, so then you guys can go enjoy your weekend. All right, so, hopefully you guys are okay with that trade-off. All right? All right. I'm not trying to be a jerk. Just want to be transparent. All right? Okay. So looking at section 7.1 here, we're going to answer a few questions here. Section 7.1. Yes, Yusuf, how are you, my friend? So section 7.1 here talks about the probability density curves, specifically talking about the normal distribution. All right, now first of all, let's talk about number 1. Number 1 says, what is a probability density curve? Basically, it's a curve that represents the probabilities of all possible continuous random variables. Okay, that's not too hard. That's stuff that we've talked about before. Okay, now the one that we want to be focusing on here is going to be the normal curve, okay, the normal probability density curve. That's the one that we'll look at here specifically in this section. But we'll talk about some properties here of any probability density curve, any curve that represents a probability distribution no matter what it looks like. It could be weird shaped, it could be whatever shape you want. There has to be two properties that's always true. First two properties are, the total area underneath that curve has to be 1, and the height of the graph must be greater than or equal to 0 for all possible values. So it has to be 0 or greater. Again, that follows suit that all probabilities has to be between 0 and 1 at the end of the day. So if you're following a probability curve, just like a probability distribution we talked about in the first section of chapter 6, well, yeah, pretty much in general, it's the same two properties we've talked about before, just stated slightly a bit differently in terms of a curve. Fine. Okay, so then what's the question that we have here is, what is the normal distribution curve? What is the normal distribution curve? So the normal distribution curve is a curve that is normal in shape. Now, do you guys remember the bell-shaped curve? Do you guys remember the good old bell-shaped curve that we talked about before? You guys, yes or no? Remember that bell-shaped curve we talked about? This was like a while ago, back in like chapter 3 or 4, something like that. So it was like chapter 3. But yeah. So I want you to go back to thinking about that bell-shaped curve from before. All right, that's the guy we're gonna look at. All right, specifically that guy. Now that guy is a very specific curve. Okay, it's a very specific curve with its own unique properties, and we're going to be using these properties here quite a bit when we study and use this normal distribution here in many varieties. Let's talk about what those are. Number 4, what are some important properties with the bell-shaped curve? First things first, if we cut that curve in half, it is perfectly symmetrical about the mean. So meaning to say, if I put it on the thing here, here's our bell-shaped curve. If I cut it in half just like so, the mean is right here. I can cut it 50-50. Okay, it's perfectly symmetrical about the mean. That's what that first property represents. Just like any other probability curve, letter B, the area under the curve is 100%. That's always true. All right, letter C, it's symmetric, perfectly symmetric. I put it as a second time because we forget the first time. And letter D follows the 68, 95, 99.7 rule. That was the AKA the empirical rule that we talked about back in section 3.2. Okay, so with all those percentages and stuff, yes, it does follow the 68, 95, 99.7 rule that we had talked about from before back in chapter 3. Okay, so do you guys kind of remember that one? The last one there, 68, 95, 99.7 rule? We talked about it a little bit. I don't know if you guys remember that. Yes? Okay, good. Good. You know, we're gonna be using that to some degree, maybe not exactly, but again, we'll be using some facets. If you remember when we talked about z-scores and stuff, yeah, that stuff's gonna be now relevant starting from this point forward, okay? All that z-score stuff, all that percentile stuff, all that junk is going to now be super relevant for what we're going to be doing moving forward here from chapter 7 on through. Okay, so you'll see how that will be applied. Now, we're not going to be talking about that here today. Today is a very super fast section, just getting this stuff done and out of the way. All right, so we'll get to the meat and potatoes here for next week. But let me go ahead and show off one more thing here. We do have to look at the textbook here specifically. So let's take a look at that. Wow, the book just crapped on me again. Come on, book. Why must you be so mean to me, bro? Alright. The book's gonna be mean. I'm gonna be mean right back. Alright, let's be mean. You don't like to be mean, you know? You know what? I might do it this way. Alright, fine, book. Have it your way if you don't want it. This book really hates me today. I don't know why. It absolutely hates me. Alright, you know what? Alright, ladies and gentlemen. Let's do it this way. I'm just going to put the book on full blast. This would normally be faster if the book didn't die on me, but that's okay. Alright, let's take a look here. Let's determine whether or not these graphs are approximately normal or not. So based on these histograms. Alright, let's look at number 19. Yes or no? Does number 19 look approximately normal? Does it look like a bell-shaped curve if I were to make it a somewhat of a bell-shaped curve? Yes or no? Does this look like a bell-shaped curve of some type? No. This doesn't look normal at all? It doesn't kind of look like a bell. It doesn't have to be exact, guys. Okay, understand, it doesn't have to be exact, but if it looks pretty close, then it can be a yes. All right? It doesn't have to be exact. All right? Because every data set doesn't follow exactly a perfectly symmetrical. Remember, what we want is we want a normal distribution, yes, but we're not going to get the exact values, okay? Again, in a perfect world, that's the ideal. So we want to be as close to the ideal as possible. So if it looks close, say yes. All right? All right, good. If it looks close, say yes, that's correct. About number 20, yes or no? Normal or not normal? What do you think? Yes, normal, not normal? No, I agree. All right, totally agree. Doesn't look normal to me. Nope. All right, 21. Yes or no? Normal or not normal? Yes, that's correct, Jasmine. It's actually skewed right. You're all right. All right, no. All right, good. 22. 22. Yes or no? 22. Yes or no? Normal or not normal? Looks pretty close. All right. All right. Good, good. See how these problems are super fast. It's like efforts. All right. Good. Is that all I wanted to do? Yes. Great. Great job, everybody. That's correct. All right. Good stuff. Okay. That's the entirety of section 7.1 in a nutshell. Good job. I know. Examples. Examples, guys. This is all I want you to do for this section. That's it. That's section 7.1. It abruptly stops right there. Literally, it just stops right there. If it looks close enough to a bell-shaped curve, it's approximately normal. If it doesn't look like a bell-shaped curve after putting all the data items together, then it's not. Simple as that. See, guys, I like to expedite the process as best as possible. All right, good job. Expediting is very fun when you don't have to put too much effort in. All right, any questions about that? Nice indeed. No questions? Hopefully everybody's fine with that. Alrighty. Alrighty. Okay, so we are going to end off a little bit early here for today, as promised. So there you go. That is the end of section 7.1. We are going to, I hope all the sections are the same. Can't make that promise, Rabia, unfortunately. I can make a promise that some are and some are not. So, some require a little bit more effort. Okay, great job, everybody, today. I want to thank everybody for coming on out to the stream once again. Thank you so very much. What should we do for homework? 6.2 and 7.1? Yes. Okay, 6.2 and 7.1 would be the ideal to do. Especially focus on 6.2. Make sure you get that wording down when you answer those questions. 7.1 should be pretty much of a cakewalk. So that's not too much of a to do there, but 6.2 is the one you should be focusing on the most. All right. Okay. Anything else, anybody? Hopefully we're good to go. All right. Thank you, Vince. Thank you. All right. Everyone, I hope you have a very fantastic day, a fantastic afternoon / weekend, okay? take care of yourselves. You have a great one as well, Alyssa. Carla, take care. Thank you. Vince, thank you. Jasmine, thank you. Thank you. Thank you, Sneaky Weasel. Thank you, Alex. I appreciate it very much. I hope everybody has an absolutely fantastic weekend. And as always, everybody, stay safe, stay healthy, but most importantly, stay safe. Alright, we will see you again next week, everybody. Same time, same place, right here on Tuesday. We're going to keep going here with Chapter 7. Alright? Yeah, we still got a week before we reach Chapter 8. So, we're still on a good pace here, Rabia. So, we're just going to take our time. Nice and easy, everybody. Alright, everybody, if you have questions, again, you know where to find me. I'm on Discord, or again, email me. You know where to find me. Otherwise, I will see you on Tuesday. Have a great one, everyone. We will see you all later. Take care, everybody. Have a great one. Bye! Bye, everybody.